Hi everyone, today I will show you how to visualize pedigrees using the R package Pedtools. If you are working with a mouse colony, keeping your lines outbred is critical to minimize effects of deleterious mutations that spontaneously emerge in your colony. Today I will show you how to go from a list of animals and parents to a complete pedigree with inbreeding scores so that you can make the best decisions in terms of future matings. So typically when managing a colony you have databases with the animals' IDs, then their father IDs, their mother IDs, the sex that can be encoded here in different ways, and the list of genotypes. So the first thing that we're going to do is to upload that spreadsheet, and we are going to use this library read Excel. So we go down here, we upload the table, and we have this table with the ID, the father ID, mother ID, and the sex. So once we've done that, we need to upload our pedigree using this ped function, to which we need to pass a vector with the ID of the animals, an ID of their fathers, mothers, and their sex. There is a problem, however, when we use the columns from our spreadsheet. Essentially, it says that the father IDs do not appear within the animal's IDs, so each parent needs also to be part of the pedigree. To solve that, we use this function over here that is include breeders, that just extends our database to include the breeders and assign to these breeders no parents. So now when we do that, we create that table. We can now load our pedigree and we visualize it, and this is what we get, a beautiful pedigree. So these pedigrees, how do you read them? You have the males as squares, females as circles. Matings are indicated by these vertical lines between two individuals, so 1 and 4 here are being made in the same 2, 5, 3, 6, and all the progeny from this mating is connected through this line, starting from this vertical line. So 13, 12, 11, and 10 will be from this mating. Now that we have our pedigree, we can have an idea of the level of inbreeding, but we could do better by adding an inbreeding score. The Pedsuite package calculates that for every individual using the inbreeding function, to which you just need to pass the pedigree. So here we are using the inbreeding function. We are giving our pedigree, so we will calculate that, and then we will plot that, and we will have here the inbreeding scores on the bottom right. We also generated a PDF to facilitate the visualization. So when we open the PDF, there is actually some space to visualize the inbreeding scores here. And also you can search for animals, which is handy. For example, we want to know where animal 27, we can look it that way. The inbreeding score goes from 0 to 1, with 0 being no inbreeding and 1 being complete inbred, which never happens. A very high level of inbreeding is 0.25, which is the level of inbreeding you have when you mate siblings. In this case, for example, we are mating 29 and 30 that they are siblings, and we are having this 0.25 score over here. An aunt and nephew mating gives you a score of 0.125, which is the highest you want to have in your colony, and only if it is extremely necessary. And a level of inbreeding between first cousins like 36 and 25 give you a score of 0.6 approximately. And this is okay to have in your colony, especially if your colony is of a few hundred animals. Before we move on, let me give you an intuitive explanation of where these scores are coming from. For example, a score of 0.25 indicates that 25% of the genome of the individual comes from a single chromosome from one or more of their ancestors. So let me try to illustrate this point. So for example, let's say that we have this mating between this male and this female, and we have for gene 1 of this male, we have the allele of the father that we are calling father A, and the other chromosome will have the father B allele, and the same for the mother. This has gene 1, and this has an allele MA and allele MB. So this mating will give us son and a daughter that we are going to inbreed, and that's where we are going to put the double line in this mating. And let's give the genotype for this gene 1, that will be, for one allele will come from the father allele A or the father allele B, and for the other allele will come from the mother, that will be mother A or allele mother B. And the same will be for the female. For this gene 1, it will come the first allele from the father, either allele A or allele B, and from the mother, either allele A or allele B. Now, when these ones gives you a progeny, this progeny in this gene 1, the first allele coming from the father can either come from the grandfather A, B, or the grandmother A or B. So the allele will be either grandfather A, grandfather B, or grandmother A and grandmother B. And the other allele will come from the mother and will have the same frequency. Either it can be from the grandfather A, the grandfather B, the grandmother A, or the grandmother B. And this actually will happen for every single gene in the genome. So gene N, again, the allele either will come from the grandfather A, grandfather B, grandmother A, grandmother B, those coming from the father, and those coming from the mother will be the same story. Will either come from the grandfather A, B, grandmother A, or grandmother B. And now the thing is, whatever this allele they receive from their father, let's say they receive the grandfather A, there will be 1 in 4 chances that this allele in the other chromosome is the very same allele coming from this ancestor. And the same is true for all of the other genes. For example, in gene N, we can have the allele coming from grandfather B, and so we have again 1 in 4 chances that from the mother they are receiving the same allele. So in sum, if any allele in any of the genes tends to be deleterious as homozygous, there are big chances, or 25% chances, that these genes will be present in homozygosity in these animals, and that is what makes this thing so dangerous. Now that we know what a good inbreeding score is, we want to predict the inbreeding score of different potential new matings. All things being equal, we would choose the breeding that give us the lowest score. Pedtools has a function called addChildren for adding children to the pedigree directly. So this is the addChildren function. We are going to mate father 33 and mother 32, and it will give us this animal that we are just labeling 33 asterisk for visualization. So we run that, and we have here this animal that indeed has the best score, actually 0, and this is the best score for all this whole generation. So this will be the most effective breeding to use. Well, that's it for today. If you like the video, please subscribe to make the content more accessible to you and to people like you in the future. If you already subscribed, please hit the like button, and thank you so much for your support.